Hello everyone, I'm Fee.
And I'm just a human. This video will be a little bit different because I don't actually have a prototype to show yet.
Oh, why not?
Well, to be frank, this project took a little bit longer than I expected, and also the parts that I have ordered have not arrived yet.
But you decided to make a video anyway.
Yeah, this will be more of a prerequisite of the problem rather than a presentation.
Okay, so what project have you been working on?
Well, since I have already made a head with sensor inputs and attached that to some wheels in my previous video, I thought that it would be a good idea to make a new prototype for the hands.
Oh, wow, interesting. But what do you mean by a new prototype? Have you already made hands before?
Yeah, making a robotic hand was actually the first robotic project that I tried to do. I know, not the most beginner-friendly, but I have never really cared about difficulty anyways.
Okay, so you made a hand before but it didn't work?
Yes, so in my early designs I was always using strings to make the fingers move. I tried to copy how human hands work with sinews and muscles, and in my first prototypes I could easily move the fingers. The tricky part though was when I tried to make the wrist.
Oh, so the fingers were easy but the wrist was more complicated?
Yes, so let me explain. At first glance, it might seem that a human hand has hundreds of different kinds of motions, but really they are just 17.
Right, okay.
There are 5 outer contraction movements, 5 inner contraction movements, and 5 rotational movements. And the wrist has 1 contraction movement and 1 rotational movement, resulting in 17 kinds of movements.
I see.
But each movement has 2 directions, so you have to think about 2 ways to do them. For example, you could have a string that pulls for contraction and a spring that pulls the finger back.
Okay, but there must be a lot of solutions to that.
Yes, but I was always convinced that strings would be the best way, so I tried using string plus spring, and I also tried using a thick string that could push the fingers back. And lastly, I used strings for both pulling the contraction angle and in the extension angle. And I actually got closer and closer to a working hand, but...
But what?
But it took so much time to just attach all the strings. And there was always friction in the way that made the strings not move at all. So it always worked in theory, but failed in practice.
Ah, and with each prototype you made you had to reattach the strings.
Yep. And when you also take into account that you might have to repair the hand in the future, even when I have a working prototype, it was simply too time-consuming of a solution.
Yeah, that seems like a waste of time.
Yeah, even though I think that if we could make hands with strings easy to build and repair, they would actually be the best solution. I think for now I have to come up with another solution.
Alright, so what is it?
Well, it's actually what I should have tried in the beginning, by using gears instead. Gears are good because they don't stretch or can be unreliable like the strings.
Right, because gears are a lot more precise.
Yeah, the only big downside with gears that I can think of is that they won't be able to perfectly fit with whatever you are grabbing. But they can still grab spherical objects like apples and still grab small things like pens, so it should still be fine.
Okay, great. So what is your current design?
Well, like I said before, the hand has 17 different movements, so I decided to make it a little bit more simple for now and only use 8.
Sounds reasonable.
Okay, so let's start with the fingers. In contrast to before, when they had 3 different movements, each finger now only has 1 single extension/contraction movement, which is controlled by this gear. This is then interlocked with the first part of the finger. But when that part moves, a second gear will also move within that part, because that gear is interlocked with a static gear inside the knuckles of the hand. And a similar design is then used in the other 2 parts of the finger. The result becomes so that when this gear moves 1 degree, all of the axes move 1 degree with a total of 3 degrees.
Oh wow, that's really smart. I didn't know you could do that with gears.
Yeah, but this is just the easy part. The hard part is the wrist.
That looks complicated, but also cool.
Yeah, this might look complicated at first, but really it is just a bunch of circular bevel gears that are double-sided. And why all this complexity, you might ask? Well, because when the wrist rotates, all of the gears are going to change their angle. The only thing that stays the same is this fixed axis point.
And that's why you have attached all of the circular double-sided bevel gears to it.
Exactly. The bevel gear axis is then attached to the first part of the underarm. And lastly, this underarm part or wrist part can then be extended or contracted using this axis. All in all, that's 8 movements that need 8 servos.
Great. And what servos did you use?
For now, I'm using 4 standard servos for the wrist and the thumb, and 4 nano servos for the fingers, but I might change that later.
Wow, that's a lot of gears. I think I understood most of it. But wait, why do you have 2 servos for the thumb?
Right. I thought it might be quite important for the thumb to have 2 axes of rotation, so I'm working on the rotation on the thumb as well. The design isn't finished yet in Onshape, but I have the idea drawn out.
Okay, cool. Well, that's everything for today, right?
Yeah, if everything goes according to plan, I should have a prototype for the hand in 2 weeks. So if you have watched this far into the video, don't forget to subscribe.
Or don't if you think you're too cool to subscribe. That's also an option. But don't blame me when the robots come and take your job, your wife and your kids and your computer and your consoles and your pets and your grandma and your...
Nope, blame me for building those robots. Anyways, see ya.